In the early weeks of March 2025, a striking revelation emerged from an American research institution that sent ripples through policy circles in Washington. The independent analysis painted a stark picture. Intelligent automation powered by advanced robotics would fundamentally transform productivity across every sector of the global economy. But the report carried a more pointed message. One nation stood alone in possessing the infrastructure, expertise, and industrial capacity to implement this transformation at scale. That nation was China. The language in the document was unusually direct. America's own researchers were warning that the fusion of China's manufacturing dominance with cutting-edge robotics could represent what they called an existential challenge to United States economic and strategic interests. These weren't hollow words or academic speculation. Just weeks earlier, during China's most-watched television event of the year, the Spring Festival Gala in January 2025, the world witnessed something extraordinary. On that stage, watched by hundreds of millions of viewers, a humanoid robot called the Unitree H1 performed with a grace that seemed to defy the limitations of machinery. Its upper body moved with the fluidity of a trained performer, executing complex choreography alongside human dancers. When it ran, the motion was smooth and organic, not the stiff mechanical gait people had come to expect from robots. The stage featured uneven surfaces, elevation changes, and dynamic lighting, obstacles that would challenge even sophisticated machines. Yet the H1 navigated everything as effortlessly as if it were strolling across a flat studio floor. This public demonstration wasn't just entertainment, it was a statement. It showed that China's robotics capabilities had evolved from laboratory prototypes to machines sophisticated enough to perform live on national television without failure. The American concerns suddenly seemed less like paranoia and more like strategic foresight. So how did China reach this level of technological sophistication in robotics? What developments allowed it to challenge and potentially surpass nations that had dominated this field for decades? And why does this advancement trigger such deep concern in Washington? If you're interested in understanding the technological shifts reshaping our world, consider subscribing to this channel. We examine the forces driving global change, and your subscription ensures you won't miss critical updates as these stories develop. Now let's examine the journey that brought us to this moment. The evolution from Japan's pioneering vision to America's dominance. To understand China's current position, we need to trace the evolution of humanoid robotics over the past quarter century. Between the year 2000 and 2010, humanoid robots transitioned from science fiction concepts into functional machines, though still primitive by today's standards. Japan's Honda Corporation led this transformation with its Asimo series, machines that represented genuine breakthroughs in bipedal locomotion. Asimo wasn't merely a robot that could stand upright. It integrated perception systems with intelligent control mechanisms, allowing it to understand its environment and adjust its behavior accordingly. The capabilities were impressive for the era. Asimo could navigate staircases, maintain a running speed of 9 kilometers per hour, and perform tasks requiring fine motor control, pouring liquids, playing with a ball, even executing simple sign language gestures. With artificial intelligence assistance, it could engage in basic conversations. When Honda unveiled these capabilities, the technology community was stunned. It shattered assumptions about what machines could accomplish. Nations across the globe responded by launching their own robotics initiatives. The modern robot age had officially begun, with Japan positioned as the undisputed leader. But leadership in technology is never permanent. Between 2010 and 2022, the field entered what experts call the high dynamic phase, a period of rapid advancement marked by machines capable of increasingly complex physical tasks. Ironically, during this era of accelerated progress, Honda made a surprising decision. It discontinued the Asimo program that had started the revolution. As Japan stepped back, the United States moved forward aggressively. American companies, particularly Boston Dynamics, pushed the boundaries of what robots could do in challenging environments. In 2013, Boston Dynamics introduced Atlas, a humanoid robot powered by hydraulic systems that could maintain balance on unstable terrain and execute movements requiring exceptional coordination. These weren't controlled demonstrations on flat surfaces. These machines operated in scenarios designed to test the limits of mechanical capability. Then came Tesla's entry into the field. In 2022, Elon Musk's company unveiled Optimus, a humanoid robot integrating advanced AI computing power. Optimus could grasp and manipulate objects weighing up to 20 kilograms and walk at 8 kilometers per hour. More importantly, its design philosophy focused on industrial applications, creating a machine that could eventually work in factories, warehouses, and other commercial settings. As artificial intelligence continued its exponential growth, humanoid robots absorbed these advances, becoming more perceptive, interactive, and capable of autonomous decision-making. The machines were evolving from programmable tools into adaptive systems. But while Western companies commanded global attention, a quieter transformation was occurring in China. The moment that changed everything. China's Spring Festival revelation. When the Unitree H1 appeared on stage during China's 2025 Spring Festival Gala, international robotics experts immediately recognized they were witnessing something significant. This wasn't a carefully edited promotional video or a controlled laboratory demonstration. This was a live performance before an audience of hundreds of millions, with no room for failure. The robots displayed upper limb dexterity that matched professional dancers in complexity and precision. The speed of movement, the variety of gestures, the seamless transitions between poses, all of it demonstrated capabilities that pushed the technological envelope. Experienced performers watching the broadcast admitted the machines executed movements that would challenge even elite human acrobats. Let's examine the technical specifications that enabled this performance. The Unitree H1 stands approximately 180 centimeters tall, roughly the height of an average adult male. Its weight of 47 kilograms makes it considerably lighter than many comparable humanoid robots, an important factor for energy efficiency and mobility. The maximum joint torque reaches 360 Newton-meters, providing the power needed for dynamic movements. Each leg possesses 5 degrees of freedom, while each arm has 4, allowing for nuanced positioning and control. In terms of speed, the H1 can walk at 1.5 meters per second and run at 3.3 meters per second. This running speed set a new world record for humanoid robots. Engineers familiar with the system suggest its ultimate athletic potential could exceed 5 meters per second, though this remains to be demonstrated publicly. Predictably, skeptics emerged immediately. Critics argued that internet videos show only the best moments, that behind these polished demonstrations lay countless failures and limitations. They pointed to established leaders like Tesla and Boston Dynamics, suggesting Chinese companies were still catching up to Western standards. Then came the report that silenced much of the skepticism. The 45-page reality check, America's own assessment. A prominent American think tank called Semi-Analysis released a comprehensive 45-page analysis that examined the global humanoid robotics industry with granular detail. The findings were stark and, for many in the United States, deeply uncomfortable. The researchers divided the humanoid robot industry into 3 fundamental components: the brain, AI and control systems, the body, physical components and mechanical systems, and the integrators, companies that assemble and customize complete systems. Their investigation revealed that 73% of companies globally are actively developing humanoid robot technologies. But the geographic distribution of this development was heavily concentrated. 77% of integration companies, those that turn components into finished products, are located in Asia. Within that Asian concentration, China dominates overwhelmingly. The numbers are striking. China controls 63% of the global humanoid robot supply chain, with particularly strong dominance in the body segment, the physical components that determine a robot's capabilities. The report projected forward to 2050, estimating that China's humanoid robot market would reach $827.1 billion, with approximately 59 million units deployed across various sectors. When the researchers examined the world's 100 publicly listed companies involved in humanoid robot development, they found that 56% were Chinese firms. Perhaps most significantly, 45% of the world's system integrators, the companies that customize robots for specific end-user applications, operate from China. These integrators serve as the crucial link between general-purpose robot platforms and real-world applications, adapting machines to meet the precise needs of factories, hospitals, warehouses, and other facilities. Financial data reinforce the trend. According to IT Orange, a market intelligence firm tracking investment flows, Chinese humanoid robot manufacturers secured nearly $2.7 billion in venture capital during just the first 2 months of 2025, spread across 20 separate funding rounds. This represented a massive increase from the same period in 2024, when only 4 deals totaling $1.6 billion occurred. The pattern was unmistakable. China's robotics sector was advancing rapidly across the entire value chain, from fundamental research through commercial deployment. Its artificial intelligence development was matching and in some areas exceeding American capabilities. 11 years at the summit, China's industrial robot dominance. But the humanoid robot story is only part of a larger picture. For 11 consecutive years, China has maintained its position as the world's largest market for industrial robots. The machines that weld car frames, assemble electronics, and handle materials in factories worldwide. The scale is honestly extraordinary. Over the past 3 years alone, more than half of all industrial robots installed globally were deployed in China. In 2023, Chinese factories added 276,000 new industrial robots, representing 51% of the global total. This marked a 144% increase compared to 2020 levels. Equally important is the shift in who's building these machines. In 2020, domestic Chinese brands held just 30% of their home market, with the rest supplied by international manufacturers. By recent measures, that domestic share had jumped to 49%. Chinese companies were rapidly displacing foreign competitors in the world's largest robot market. This growth wasn't scattered randomly across the country. It concentrated in industrial clusters, particularly in the Yangtze River Delta surrounding Shanghai and the Pearl River Delta near Shenzhen and Guangzhou. More than 3,000 companies now operate in China's robotics ecosystem, creating dense networks of suppliers, manufacturers, and research institutions. Perhaps the most strategic achievement involves what industry analysts call core components, the critical technologies that determine a robot's capabilities and that historically gave foreign manufacturers their competitive advantage. These include precision reducers, servo motors, and control systems. In 2015, China's self-sufficiency rate for these core components stood at just 40%, meaning the majority had to be imported. By recent assessments, that figure reached 68%. Some Chinese companies have achieved even higher rates. Siasun Robot and Automation has localized 95% of its core components, while Estune Automation's control systems are 82% domestically sourced. Compare this to the United States, where domestic robot manufacturers hold only 18% of their home market, and where import dependence for core components exceeds 60%. The contrast reveals divergent trajectories. One nation building comprehensive domestic capabilities, another increasingly dependent on foreign suppliers. The mass production breakthrough, from laboratory to assembly line. Technical demonstrations are one thing. Mass production is entirely different. It requires not just working prototypes, but manufacturing processes capable of delivering consistent quality at scale and competitive prices. China has achieved this transition in humanoid robotics. The Unitree G1, for example, comes equipped with proprietary force control systems and motors that don't require rare earth materials, a significant achievement given that rare earth processing has geopolitical implications. The G1 achieves repeatability accuracy of 0.5 millimeters, operates for 2 hours on a single charge, can carry loads up to 15 kilograms, and sells for approximately $16,000. Consider that price point in comparison. Tesla's Optimus, still largely confined to laboratory testing, carries estimated production costs exceeding $200,000, more than 12 times higher. The Optimus battery provides roughly 1 hour of operation, half the G1's endurance. These aren't minor differences. They represent fundamental gaps in manufacturing capability and cost efficiency that determine whether a technology remains a curiosity or becomes commercially viable. The cost advantages extend throughout the production chain. A detailed analysis of a 5-kilogram payload robotic arm found that manufacturing costs in China run at 45.7% of equivalent American production, less than half the expense. Breaking this down reveals where the advantages originate. Rare earth permanent magnets, essential components in high-performance motors, cost 64% less in China thanks to 90% domestic production capacity. Servo motors, benefiting from large-scale manufacturing volume, cost 30% less. End effectors, the hands that allow robots to manipulate objects, cost 66.7% less due to vertical integration of the supply chain. These aren't advantages that competitors can easily overcome through incremental improvements. They reflect fundamental structural differences in industrial organization and supply chain architecture. The foundation, the world's most complete industrial system. China's robotic success doesn't exist in isolation. It rests on what economists describe as the world's most comprehensive industrial system. Manufacturing value added produced in China accounts for approximately 30% of the global total. Nearly 1/3 of all manufacturing value created worldwide originates in Chinese factories. The production volumes are, well, staggering. In 2023, China manufactured 1.2 million industrial robots, produced lithium batteries with 1,200 gigawatt-hours of capacity, and created 250,000 tons of rare earth permanent magnets. This combination of volume and diversity creates synergies that are difficult to replicate. A robotics company in China can source virtually any component domestically, often from multiple suppliers, ensuring both cost competitiveness and supply chain resilience. The contrast with the United States is stark. Since 2000, America has lost 7 million manufacturing jobs. The country's robot density, measured as robots per 10,000 workers, stood at 260 units in 2023, and its growth rate has slowed considerably. While the United States remains technologically advanced in certain areas, its industrial base has contracted significantly. Strategic investment policy as competitive advantage. Technology development requires more than just market forces. Strategic government support often determines which nations lead and which ones follow. For example, China designated robotics as one of 7 strategic emerging industries in its 14th five-year plan, which, by the way, is a comprehensive economic roadmap that guides national development priorities. In 2023 alone, the Chinese government allocated $10.6 billion in targeted subsidies to the robotics sector. This public investment actually catalyzed more than $68.9 billion in private industrial investment. On the other hand, the United States, despite passing the CHIPS and Science Act to boost domestic technology sectors, provided comparatively limited support specifically for robotics. As a result, research and development investment intensity at American robotics companies runs at approximately 60% of the level seen at Chinese competitors. This funding gap translates directly into capability gaps. After all, money determines how many engineers you can hire, how many prototypes you can test, and how quickly you can iterate through design generations. Technical breakthroughs. The details that define leadership. Beyond financial metrics and production volumes, technical specifications really tell their own story. Force control accuracy, the precision with which a robot can modulate the pressure it applies, has reached 0.1 newtons in Chinese systems, placing them at the international advanced level. This matters enormously for applications requiring delicate manipulation, from assembling electronics to handling fragile objects. Visual recognition accuracy in Chinese robot systems has hit 99.97%. Achieved through machine learning models trained on more than 1 million hours of labeled data. This allows robots to identify objects, navigate complex environments, and respond to visual information with near-perfect reliability. Motion control response time has reached 1 millisecond in advanced Chinese systems, which actually compares favorably to the 2-millisecond response of ABB's Yumi robot, a benchmark in collaborative robotics. Research and development spending intensity, the percentage of revenue invested back into innovation, tells another part of the story. Siasen Robot and Automation invests 15.45% of revenue in R&D. Estune Automation invests 14.67%. Compare this to Fanuc, the Japanese industrial robot giant, which invests 5.14%. Chinese companies are outspending established leaders by factors of 2 to 3, accelerating their technical evolution. The patent war. Intellectual property as strategic asset. Patent filings offer a window into future capabilities, revealing where companies and nations are concentrating their innovation efforts. China has filed 6,618 patent applications in humanoid robotics, the highest number globally. For valid invention patents, those that have been examined and granted, China ranks second worldwide with 1,699, trailing only Japan. Individual Chinese companies are now surpassing historic leaders. Ubtech Robotics, for instance, holds 763 valid patents, exceeding Honda, the company that pioneered the field with Asimo. By July 2024, according to China's Ministry of Industry and Information Technology, Chinese entities held more than 190,000 valid robot-related patents, approximately two-thirds of the global total. This intellectual property foundation provides both defensive protection against competitor claims and offensive capability to license technology and set industry standards. From demonstration to deployment, real-world applications, that's where the rubber really meets the road. The true test of any technology is whether it solves real problems in real environments. China's humanoid robots are moving rapidly from demonstration stages into operational deployment. The commercial pathway is logical and sequential. Initial applications focus on industrial inspection and logistics handling. Environments where the business case is clear and the operating conditions are, relatively controlled. From there, expansion moves toward medical facilities and eventually home environments as the technology matures and costs decline. Ubtech's Walker S1, deployed in BYD automobile factories, has increased operational efficiency by 100% while improving stability by 30%. These aren't marginal gains. They represent transformative improvements in manufacturing performance. The Walker S has secured more than 500 letters of intent from various automobile manufacturers and is currently scaling toward full industrialization. This really represents the transition from prototype to product, the moment when a technology shifts from interesting possibility to economic reality. The decline of the giants, market share and transition. For decades, 4 companies dominated industrial robotics globally: ABB, Fanuc, KUKA, and Yaskawa. Their collective market share was taken as evidence of an insurmountable competitive advantage based on decades of expertise and established customer relationships. But that dominance is eroding. ABB's market share has fallen from 22% in 2018 to 15.68%. FANUC has dropped from 18% to 11.46%. The pattern is consistent across the traditional leaders, slow but steady market share decline. Meanwhile, Chinese companies are expanding internationally through strategic acquisitions. KUKA itself, one of the traditional Big Four, was acquired by Chinese interests, with production capacity increasingly shifted to Asia. Other German and European robotics companies have been absorbed into Chinese corporate structures, transferring both technology and expertise. The global robotics market overall shows stagnant or declining growth in most regions. China is the notable exception, the only major market experiencing sustained expansion. This creates a gravitational pull, drawing investment, talent, and innovation toward the Chinese ecosystem. Projections: the trajectory through 2030 and beyond. Looking forward, the trends appear likely to accelerate rather than reverse. Analysts project that by 2030, China's robot density will exceed 1,000 units per 10,000 workers, nearly quadruple the current American level. The humanoid robot market within China alone could reach $500 billion, while manufacturing automation rates climb to 85%. Technology maturity curves suggest that collaborative robots, machines designed to work safely alongside humans, will achieve 65% market penetration within 5 years. Humanoid robots, currently in earlier deployment stages, are projected to reach 40% penetration within a decade. These aren't merely economic projections. They represent a fundamental restructuring of how goods are produced, how logistics are managed, and ultimately how economic value is created. American anxiety: strategic implications of technological shift. The American response to these developments has grown increasingly pointed. Following the release of the Comprehensive Robotics Industry Analysis, U.S. lawmakers and policy experts expressed serious concerns about national security implications. Their anxiety isn't purely economic. The fundamental issue involves the role of artificial intelligence and robotics in future military capabilities and geopolitical competition. Modern warfare increasingly incorporates autonomous systems, drones, robotic vehicles, automated weapons platforms. The nation that dominates artificial intelligence and robotics technology gains enormous advantages in military capability. Strategic competition in the 21st century may be decided less by traditional measures of power and more by technological superiority in automation and AI. If China establishes clear leadership in these foundational technologies, the implications extend far beyond commercial markets.